Welcome folks, in this video we are going to look at the question C2. This question is coming from section C of Science Paper for the year 2022. Now the question reads, figure C2.1 shows a learner viewing an activity over a fence using the instrument shown in figure C2.1. Right, so we are given an instrument, and this instrument is used in construction, or we can just say is used to seize things that you cannot see, or we can just say things behind something that you consider to be an obstacle. For example, the offense here is acting as an obstacle. Right, so the first question that we have here is, name the instrument used in figure C2.1. So this instrument is called a periscope. Alright, then we move on to question Roman number 2. Copy and complete figure C2.1 by drawing a ray of light to show how the learner viewed the activity on stage. So, and this one, the learner is acting as an observer. Then if this is our observer, then whatever that is on the stage, these are our objects. Now since we have objects, we should also expect to have image. So the image is formed in the eyes of the learner. Now how do we draw the ray of light to show how the image is formed? So what you need to know is these two plane mirrors are there to direct light from the object into the eyes of the observer. So you draw a straight line from the object onto the plane mirror. So make sure you use the a rule. Then since we have a plane mirror at an angle 45, we're expected to have reflection, so this will bend. Then here again it will bend. Then this will be directed into the observer's eyes. So this is what you're supposed to do, and make sure that if the person is acting as the observer, then the direction should be from the object into the eyes of the observer. Now we can move on to question B. So B reads, figure C2.2 shows a glass prism with one face labeled AB. The refractive index of the glass prism is 1.5. Then the first question is, define the critical angle. So the definition for critical angle is, so this is the angle of incidence. When the angle of refraction is equal to 90 degrees. So as long as if the angle of refraction is equal to 90 degrees, then the angle of incidence that you are dealing with is the critical angle. And in some textbook, the one that I usually use, the symbol for critical angle is IC. Right, then we move on to Roman number 2. Copy and complete figure C2.2 to show a narrow beam of light which is incident on the face AB of the glass prism until it merges out of the prism. So for this one, the AB, this one is acting as a boundary. So we are going to now draw a straight line. Then we are not going to have any refraction since the line is hitting the boundary at an angle of 90. So we are not going to have the reflection. Right, so now if this is a right angle triangle, and we know that a right angle triangle adds up to 180. So if this 90 at angle B, we can find the angle at A. So angle at A plus this 45 must add up to 90. So here we are going to have 45. Remember, this is 90, this is 90, this is 90, this is 90. Now if this angle is 90, then this angle must equal to 45. Why do we say 45? So that if we add 45 plus this 45, we are able to get 90 plus the 90, this one, we are able to get the 180 as the sum of the right angled triangle. Now, what happens if this line hits here? So we are going to have the reflection will be in this direction. Why do we say this is our refraction? I mean, the bouncing or bending of light will go in this direction. So what angle is this one? Remember, if this line is perpendicular to this line, then the angle at this point is 90 degrees. 90 plus 45 is 135 minus 180. This is 45 also. So if this is 45, then this angle is 90. If this angle is 90, this is the angle of refraction. And whenever the angle of refraction is 90, then we are dealing with the critical angle. So that is the point that we are looking at. So to summarize our work, we are saying this is the answer that you're supposed to give under Roman number 2. Then we move on to Roman number 3. Calculate the critical angle of the glass prism. So we are going to apply the formula. The symbol for refractive index is small letter n, which is equal to 1 over sine of critical angle. Then where there is n, we are going to substitute with the 1.5 since it's given. Then we are going to cross multiply. So our task is we need to solve for IC. So we cross multiply. So 1.5 times sine IC, this is 1.5 sine IC. Then 1 times 1 is 1, so we divide by 1.5 here by 1.5. So sine IC is equal to, so 1.5 1 divided by 1.5, so according to my calculator I'm getting 0.6666, so you can just say 7 here. Then we'll do we now bring in the trigonometry, so the sine will shift to the right side. So we have IC is equal to, so we have sine of inverse of 0.6666. Then on your calculator you press shift, then sine 0.6667 is equal to 41.80 degrees. So if I round this one off, I'm getting 42 degrees as my critical angle. So this is how we can find the critical angle for this one. Or if what we can, if we are to just make IC the subject of formula, so this is n is equal to I divided by sine IC, which is over 1. We cross multiply, so n sine IC is equal to 1. So we divide by n, also here by n, so that if we cancel, we'll have sine of critical angle is equal to 1 over refractive index. So we shift this one to this side. We have IC is equal to the inverse of sine of 1 over n. So this is the formula to use for critical angle, where the critical angle is the subject of the formula. Now we move on to Roman number 4. Give 2 uses of total internal reflection. So the first one, it can be used in telecommunication. Then the second one will have optical fibers. Right, so these are solutions to this question. Now for those that are writing the exams next year for the GC, even the grade 12s, so the best help that you can give to yourself is you need to start studying and your tuitions as early as possible For that, you are going to at least have enough time to study to avoid the cramming when the exams comes. So, and for those that want the online tuitions, I offer online tuitions, and with me I will be taking you at your own pace. So that's it for this video. Thanks for watching.